All right, product property, quotient property, and power property. So basically what they were reminding you of is the properties of exponents that you should be familiar with, right? If you multiply like bases, you add their exponents. If you divide like bases, you subtract their exponents. If you have a power to a power, you multiply. And so because logarithms are the inverse of your exponential functions, those same things kind of apply to the logarithms. Multiplication can be separated by addition, just like this guy right here. You're multiplying your like bases, you add your exponents. And so since we are dealing with the exponent piece of the function, since the logarithm is the inverse, if you have a log of two numbers that are multiplied, you can split those up. This is going to help us when we start solving log equations, all right? So while this seems like a weird process now, when we start solving it, it's actually going to help us. Division then, just like this one right here, with exponents, you subtract their exponents. If you are taking the log of two numbers that are being divided, you can separate the individual logs with subtraction. And then here, my exponent, remember exponents multiply. If I have an exponent within my log, I can take it out and put it in front, okay, and expand it that way. All right, and so they start off showing us using numbers. So look at example 1. It says write each logarithm in terms of ln of 2 and ln of 3. All right, so I will say, when you're given something like this, unless you just know off the top of your head that expansion, I would actually use my factor tree here. So I would say 2 and 27, 3 and 9, 3 and 3. I would write this in my primes with powers, okay? So 54 can be written as 2 times 3 to the third. All right, y'all remember doing that in like upper elementary, middle schoolish, where you broke it into primes? So that means if I want the natural log of 54, I can say, well, that's the same thing as the natural log of 2 times 3 cubed, right? So I just split it up that way. And then I'm going to use my properties. I have a property for multiplication. My multiplication property says I can split these up with an addition, all right? So I can say ln of 2 plus ln of 3 cubed, right? That's my product property. Because they're being multiplied, I can split them up with an addition sign. All right, I have an exponent property here that tells me I can move that in front. So I have the natural log of 2 plus 3 times the natural log of 3. And that is the expansion of that one. All right. Next one, they specifically said using 2 and 3. So I'm going to rewrite this one. How can they rewrite 9 in terms of 3?
3 squared.
Yeah, 3 squared. How can I write 8 in terms of 2?
2 to the third.
Yep, 2 cubed. And so now I can expand. Division. My quotient property tells me I can say this is the same thing as 3 squared minus the natural log of 2 cubed. And then my next expansion would move these exponents. 2 natural log of 3 minus 3 natural log of 2. So for this one, they have log base 4 of the 5th root of 64. So remember that roots can be rewritten as exponents, right? So 64 is to the first power. So I can rewrite this as log base 4 of 64 to the 1/5, right? 64 to the 1/5. Now, Maybe you do, maybe you don't. But you might recognize that 64 is a multiple of 4, right? It's actually a power of 4, okay? So if I take 64 and break that down, it's actually 4 to what power? I know this. So I know it was y 4, right? Which gives me 16, right? So this is actually 4 to the 3rd power, correct? And so I can actually rewrite the 64 as 4 to the 3rd, right? Everybody see that? So what do I do? We just talked about this. I have a power to a power. What do I do with those powers? Multiply. So I log base 4 of 4 to the 3/5. What happens between this log base 4 and that 4? What happens? Bases cancel out bases. They're the same. They cancel out. So this equals 3/5. That is my answer. So log base 4 of the 5th root of 64 is 3/5. That's how that works. All right. Let's look at the next one. See how this helps us. Condensing. All right. So condensing and expanding may potentially help us. This 2, if I want to expand it, where can I put that 2? Where can it go? My product rule of my expansion tells me it can go in front, right? So I have 5 times 2 ln of E minus ln, and I should do the same thing over here, minus 3 ln of E, right? So far, so good? Does that make sense? My ln of E's do what? Yeah, ln of E and ln of E will cancel, so I just have 10 minus 3, which is 7. Wow. All right, so try A and B there. While it doesn't seem like you're actually solving anything right now, the reason is we're going to actually do some log equations, and condensing and expanding will help you do the log equations. So we're just doing the process of expanding and condensing here in this section, and then as we move on, we'll actually use it to solve equations. So what they want us to do is they want to expand these completely, as much as they can be expanded. All right, and so you have to look at all the pieces of it. So I have a multiplication here, and I always look between the variables, not really between the numbers. So we'll look at the variables first. We have a multiplication between the two variables. We do have a multiplication between the 12 and the x, all right? And then we have some exponents that we're going to expand as well, all right? So let's look at these. I can break up my multiplication how? With what? Multiplication breaks up using addition. So I'm going to say log of 12 plus log of x to the 5th plus log of y to the negative 2. All right? I'm not done expanding. I still have exponents. What do I do with those exponents?
Put them to the front.
Put them in front. So I have log 12 plus 5 log of x, and this, because this is a negative, I'm just going to say minus 2 log of y. That is completely expanded. I cannot expand it anymore. Let's look at the next one. All right, I have division going on here between those two groups. So the first thing I'm going to do is I'm going to split it up by what? Subtraction. Now, for this one, I'm going to rewrite this square root. How do you think I'm going to rewrite this guy? 4x plus 1 I don't want a radical, I want an exponent. Yeah, to the 1/2. Yes. Now those exponents can be moved in front. 2 ln of x minus 1/2 ln of 4x plus 1. That is completely expanded. So go ahead and expand those two. So for this one, I actually am subtracting between the top and the bottom here. So I'm subtracting between this one and this one. But this one can actually be broken up by addition. But that whole group is being subtracted, okay? So you want to make sure you group it so that that negative extends through, okay? Pay attention to your positives and negatives there. Just like we expanded, we can condense the same way. You're going to look for a couple of things. One, in order to condense, they have to have the same base. You'll notice on my last one, I had base 13 written every time I wrote my log. You must write your base when you expand. When you condense, you must check your bases. If they are not the same base, they cannot be condensed, okay? So first, these are both log base 3, so I know I can condense. I can only condense between the logs, meaning this x plus 6 will never change because it is the log of that entire group, okay? We're only condensing between the logs, meaning my final answer should have one log in it, all right? The first thing I want to do is I want to look for those exponents. While my exponents was the last thing as I was expanding, it's going to be the first thing as I condense. So I'm going to take these exponents first and put them up in the top. So I am going to say log base 3 of x to the 4th minus log base 3 of x plus 6 to the 1/3. All right? Now, once I do that, I can see I have subtraction. Subtraction will condense how? With division. Log base 3 of x to the 4th over log base 3 of x plus 6 to the 1/3. I can rewrite that to the 1/3. What is something to the 1/3? The cubed root. So this is going to be log base 3 of x to the 4th over log base 3 of the cubed root of x plus 6. All right? Yeah, we will. I was about to circle that, but we don't. So we're going to condense. Yeah, we actually should have just done this. All right. Wow. So you don't even need this step here. You can go straight to that one. We just need one log here. Yeah, you don't need to list it twice.
That second one is super.
Down here at the bottom, the -5 went to the top, to the -5th, multiplied by 6 cubed. And then why did it go back down to the bottom, you think? Why did this go back down to the bottom? My exponent is what? Negative, and so it bumped it to the bottom. Here, both of these were subtracted, so both of these were on bottom. Okay, so for this one, the natural log, 3x plus 5 went on top. This became x to the 4th. These were both on bottom because they were both being subtracted. Both being subtracted there, so they ended up on the bottom. All right. So to do a change of base formula, you can program your calculator, but then you have to go in every time and do it, which is kind of a pain, depending on what type of calculator. This will also do it for you. You can always do any base, but on your calculator, natural log and log are already there. And so let's say I have this one base 3. I can use my calculator and just do this division. I can do the division of the top by the bottom. So if I want to do log base 3 of 5 and find it on my calculator, I can just do the log of 5 over the log of 3. Make it a division problem. That will be the same thing if I choose to use ln. If I use ln, I will get the same answer. When you do that, you will get approximately 1.47. It doesn't matter whether you use log or natural log. It works for any conversion, any change of base conversion. So I can convert from any base to this and solve for it. So for the next one, I could say log of 6 over log of 1/2. Just know that the base of the log goes in the base of your fraction, okay? So that 3 went to the denominator, that 1/2 went to the denominator. All right.
Is 5b 1.29?
This one. This one is approximately -2.58. All right. So you can try those, doing change of base, those 3.